Hi, I'm Mr. True. In this video, we're going to be solving rational equations. Now, that's just an equation that basically has one or more fractions in it. We've already done a video where we had fractional or rational coefficients. Now we're going to have, possibly some variables, actually with all these examples, we're going to have more algebraic fractions where we have the variable in the denominator of these fractions. It's not just a fractional coefficient. So we have 5 over 2x minus 1 equals 3 over x. This only has one fraction on each side of the equation, so we can solve this or start the solving process by cross-multiplying the equation. But to be consistent through all the examples that I'm going to work in this video, I'm just going to say the first step of solving an equation with a bunch of fractions in it is basically just multiply by the lowest common denominator. Now, that's going to mean that you may or may not have to do any factoring. In this example, we're not. We're just going to go through the denominators, if need be, do some factoring, and find all the factors, and then we're going to group all those factors together and then multiply it through the entire equation, or an equality, though this video is only for equations. And that is going to cancel out, we're just going to try and cancel out the rational expressions or the fractions as quickly as possible to simplify the work. So what that means for this equation here is we have a factor of 2x minus 1 and another factor of just simply x. So we're going to multiply both sides of the equation by x, that's this factor, and 2x minus 1, that's the factor, or the denominator that we have in the other fraction, and take this entire grouping, this entire x times 2x minus 1, and multiply that through the entire equations, or both sides of the equation. When we do that, we're going to get 5 over 2x minus 1 times x times 2x minus 1. This is just sort of like an academic step. I'm not going to show this much work in all my other examples. Equals 3 over x times 2x minus 1. Now, of course, the purpose of this is so that we find all these factors that are in our denominator and multiply by the lowest common denominator. That will allow us to cancel out the denominator. So we have a division of 2x minus 1, and we're multiplying by 2x minus 1, so those are going to factor out. And this other term of 3 over x, that denominator of x is going to cancel out with this factor of x that we're multiplying through. And we get 5x is equal to 3. Well, the x's cancel out, so we have 3 times 2x minus 1. Now we're just going to go through and solve this equation, like I've been learning how to solve equations all the way through algebra and algebra 2. In this case, we only have a linear function, so we're going to go ahead and be able to isolate that x. First thing, though, is, of course, distribute through the parentheses, so we're going to get 5x equals 3 times 2 is 6x, and 3 times negative 1 is negative 3. I'm going to bring it up here because I'm running out of room. And because I only have a single degree or a linear function, I can just, work it around so I get the x completely isolated. I'm going to do that by bringing this 6x, this positive 6, over to the left-hand side through subtraction. 5 minus 6 is negative 1x. Divide both sides by negative 1, and we get x is equal to 3. Now, none of my examples are going to have this issue, but it's very, very possible that when you find a solution, it is not going to necessarily be a solution to your original problem. So you really want to make sure that you go back and you check to make sure that all of these answers work. You don't want to, do a bunch of correct algebra, get an answer, and it's what your algebra led you to, but actually say it's a solution when it doesn't actually solve the original problem. It's possible that you get some extraneous solutions. So we're going to take this 3 and plug it back in. We get 5 over 2 times 3 minus 1 over, or equal to, 3 over 3. So we have 5 over 2 times 3 is 6, so we have 5 over 6 minus 1, which of course is equal to 5 over 5, which is equal to 1. And our left-hand side is 3 divided by 3, which is also equal to 1. So we've gone ahead and we plugged our solution into the original problem, not the one that you got after multiplying everything by your lowest common denominator, and make sure it actually does work. So ours does. Let's get on to the next example, shall we? Here we have another pretty straightforward question. We have negative 3 over x plus 4/5 equals 7 over x. The reason why I'm doing this problem, which is very similar to the previous example, is that our final solution is going to be a fraction, and when you plug that fraction back in to check your work, you're going to have complex fractions, and I want to make sure you see how to simplify those and check your answer. So we have a factor of x in this denominator, a factor of 5 in this denominator, and if we multiply the entire equation through by 5x, just a second, sorry for the interruption there. So we're going to multiply again both sides by 5x, the lowest common denominator. So when we do that, 5x times negative 3 over x, well, this is going to get canceled out, the x's. So we're going to end up with just simply 5 times negative 3, which is negative 15. And then take that 5x and bring it through to the second term. Now this time when we cancel, I showed that cancellation of x. I probably shouldn't have done that because of course, you know, every term is going to be different. So when we did 5x times negative 3 over x, the x's are what cancels out, giving us negative 15. And then when 5x gets multiplied to the second fraction, it's that factor or that denominator of 5 that's going to cancel out, leaving us with just x times 4. So we'll have plus 4x equals, now 5x times 7 over x. This time we just do have the one term, so the x's are going to cancel out, and we get 7 times 5 is 35. Well, again, this one is a fairly straightforward question, so we're just going to add 15 to both sides. And get 4x is equal to 35, and 5 is 40, and another 10 is equal to 50. We're going to go ahead then and divide everything by 4 to undo that multiplication of 4 that's on the x, and we get x is equal to 50 over 4, or 25 over 2. Now, again, when you have to multiply an expression, you know, an algebraic expression, or I guess a polynomial, if you will, through an equation to try and cancel out these denominators, you do run the risk of having a solution that, you know, may be a solution for your modified equation, but will not be a solution for the original problem. So please make sure you plug that back in and check it. This is not just a sort of check your work to make sure you did not make any mistakes. It's to check your work to make sure you have not found an extraneous solution. So we're going to take this 25 over 2 and plug it back into the original problem, and so our check is going to look like negative 3 over 25 over 2 plus 4/5 equals 7 over 25 over 2. And I do have a video, you know, explaining step by step very slowly how to simplify what these are called complex fractions. I'll just quickly say that let's not forget that a fraction bar is a division symbol, and so this is negative 3 divided by 25 over 2. We're going to change that division to multiplication by flipping up the denominator and multiplying by that second fraction. So this is going to be negative 3 over 1 times 2 over 25 plus 4/5, and let's make sure that that actually equals 7 over 1 times 2 over 25. You might be doing this in your head. I'm doing it for teaching purposes where I'm showing my work, of course. Negative 3 times 2 is negative 6 over 25 plus 4/5. I'm going to leave some room because I know I need to find a common denominator here to make sure that these can get added together. And 7 times 2 is 14 over 25. Now I cannot add negative 6 over 25 by 4/5, so I'm going to multiply this by 5 in the numerator and denominator and make that common denominator of, well, let's see, 4 times 5 is 20 over 25, which is 5 times 5. So negative 6 plus 20 is 14 over 25, our common denominator, and it looks like we got a solution that does work. Next example. So we have x minus 1 over x plus 5 plus x plus 3 over x plus 4 equals x plus 1 over x plus 4. We don't need to do any factoring here. None of the denominators can be factored. We have a denominator or factor of x plus 5 and x plus 4. So we're going to wrap this fraction or this equation with a set of parentheses and multiply every single one of the terms or both sides of the equation by x plus 5 times x plus 4. Now again, there's three terms. So 1, 2, and 3. And I'm going to do the cancellation as we go through this. We're going to take x minus 1 times or over x plus 5 and multiply it by x plus 5 times x plus 4. Now this denominator of x plus 5 is going to cancel out with this multiplication of x plus 5, and we'll end up with x minus 1 times x plus 4 plus, okay? Well, now when we get to the second term, this division of x plus 4, that's what a fraction bar is going to cancel out with this multiplication of x plus 4, giving us x plus 3 times x plus 5 equals, the x plus 4 cancels out with the last term, or the only term on the right-hand side of the equation, and we end up with x plus 1 times x plus 5. Well, now we've got a lot of simplification to go through before we can solve this for x. A lot of distributive properties to do. We have, and every time I do one of these, you can say FOIL if you like, I just draw these lines to represent all the multiplications. Every term in the first polynomial needs to get multiplied to every term in the second polynomial. So we have x times x is x squared, then we have 4x and negative 1x, and then minus 4, plus x times x is again x squared, 5x, plus 3x, plus 15, and then x times x is x squared again, plus 5x plus x plus 5. Well, we've got a lot of like terms to add up here. We have x and x is 2x squared. We have 4x minus 1x is 3x. Now we have 3 and 5 is 8x. And then plus another 3 is 11x. We have negative 4 and positive 15. So 15 minus 4 is 11. Equals x squared. We have 5 and 1, which makes 6x. Plus 5. Okay. Now see, I have second degree terms and first degree terms, so I'm not going to be able to isolate x alone. That means we need to get this equation set equal to 0 and then either use completing the square or factoring or the quadratic formula, something to finish attempting to solve this problem. We're going to bring this x squared over with subtraction, so that's going to be 2x squared minus x squared is 1x squared. We're going to bring this positive 6x over again with subtraction, so 11x minus 6x is going to be 5x. And then finally, 11 minus 5, because that's positive as well, so we need to bring it over the equal sign. We always do the opposite math operation. So 11 minus 5 is equal to 6. Okay, just making sure I don't make a small mistake here. Good. Now, again, this could be not factorable and you have to use the quadratic formula, but it is factorable. We're looking for factors of 6 that add to be 5, and that's going to be 3 and 2. So we have x plus 3 times x plus 2 equals 0. This function is now factored in its factored form. We finish that by setting each factor equal to 0. So we have x plus 3 equals 0 and x plus 2 equals 0. That means our solutions are negative 3 and, again, negative 2. So that was a good bit of work to get that solved, and, again, possibly one of these solutions may not actually work for the original problem. So I'm going to go ahead and pause the pause the video, and I'll write out those checks for you to see them, but maybe you should stop and make sure that they work as well. We'll be back with the solution and then move on to the last example. Here we can see that I plugged -3 everywhere there was an x in the original problem. Found, add everything together and got -2 equals -2. I plugged in -2 everywhere there was an x in the original problem and saw that I got the same answer, or the same numerical value on both sides of the equation again. So both of our solutions of -3 and -2 work. Let's go on to that last example. So we have 2 over y plus 3 plus 3 over y minus 4 equals 2y minus 2 over y squared minus y minus 12. So on our last term, or the only term on the right-hand side of our equation, we have a denominator that's a quadratic trinomial. And over here, of course, we have binomials. So I'm guessing that this is going to be factorable. Well, we have a leading coefficient of 1, so we're just going to look at the constant. Are there factors of 12 that subtract to give us -1? We have 1 and 12, we have 2 and 6, and we have 3 and 4. So we have a -12. That means if I take -4 and +3 and multiply them, I get -12. And -4 plus 3 is equal to -1. So this is factorable to become y minus 4 times y plus 3. So now if I take, go through all my denominators and my rational expressions, my fractions, and y plus 3, y minus 4, y minus 4, y plus 3. Okay, so if I multiply by the LCD, which is going to be y minus 4 times y plus 3, basically just take all those factors and multiply them together. Put that through the entire equation, all my fractions go away. So, off to the first term, the second term, and finally the third term. So when I take y minus 4 times y plus 3 again and multiply it to the first fraction, the y plus 3's are going to cancel out, and we get 2 times y minus 4 plus 3. The y minus 4 is going to cancel out, so we have plus 3 times y plus 3 equals, y minus 4, y plus 3, y minus 4, y plus 3, everything cancels out, and we just get 2y minus 2. So we're going to distribute through those parentheses. 2y minus 8 plus 3y plus 9 equals 2y minus 2. We're going to add all those like terms. We have a 2y and a positive 3y. We have -8 and positive 9. Make sure you carry those signs properly. Always look to the left to make sure if the numbers or term is positive or negative. So we have 2y plus 3y, which is 5y. -8 plus 9 is positive 1, equals 2y minus 2. We're going to subtract both sides by 2y. Subtract both sides by 1, and we get 5 minus 2 is equal to 3y. Let's see here, this cancels out, this cancels out. -2 and -1 make -3. Divide both sides by 3, and y comes out to -1. Like I said in the video, all my solutions ended up working for the original equation, but it's very, very easy with these problems to get extraneous solutions. So please make sure you take those and plug them back in and check that they actually work. So let's do that. We have 2 over -1 plus 3 over -1 minus 4 equals 2 times -1 minus 2 over -1 squared minus a -1 minus 12. We have -1 plus 3 is 2, so we have 2 over 2. We have 3, I don't know why I wrote a plus sign there, plus 3 over -1 minus 4 is -5. Now, I'm adding by 3 over -5, or I'm adding by a -3/5. It doesn't matter if the negative is here, or in the middle. It's still a -3/5 fraction. So instead of writing plus negative, I'm going to bring that negative out front. Just say it's minus. Okay? Equals 2 times -1 is -2, minus 2 is -4. We have -1 squared is 1. A negative and a negative make a positive 1 minus 12. Okay, so we have over here, we have negative 4. 1 plus 1 is 2. Minus 12 is negative 10. So that's going to reduce down to 2/5. Because 4 and 10 are both even, so we divided the top and bottom by 2. And just a second. Sorry for the interruption there. We need a, let's see, we have, need to be common denominator. So we're going to multiply this by 5, top and bottom. We're going to multiply this by 2, top and bottom. And we have 10 over 10. 3 times 2 is 6, so 6 over 10. And 10 minus 6 is 4. Sort of thinking of the answer there. 4/10 and, oh, well I can stop right there because I have matching values. 4/10 equals 4/10 or 2/5 equals 2/5. That's the end of my last example. Go do your homework.